This is the example problem for Unit 2 Energy, Complete Problems 3, Specific Heat. The problem says a chunk of copper, specific heat of copper is 0.385 joules per gram degree Celsius, at 100 degrees Celsius is placed in room temperature water. The copper's temperature decreases to 31.7 degrees Celsius and it releases 676 joules of energy. What is the mass of the copper? We look in the problem and see what values we have. We have 0.385 joules per gram degree Celsius tells us this is specific heat. 100 degrees Celsius is temperature. We have another temperature here because of degrees Celsius. And we have energy. We know that because of joules. We have a temperature going on. We're looking for mass. We have energy and specific heat. So we can use the equation Q equals mc delta T. We know Q. We're looking for M. We know C. We need to find delta T. To find delta T, we can use the equation delta T equals final minus initial temperature. It says the chunk of copper is at 100 degrees, and then it's placed into water, and its temperature decreases to 31.7 degrees Celsius. Therefore, its final temperature is 31.7, initial is 100, and the change in temperature is negative 68.3 degrees Celsius. Now we can plug that back in up here along with the other values. We have Q, which is negative 676. The reason this is negative is because this amount of energy is released. And so when we're using that in the equation, that's a negative. Equals M, which we don't know, C, which is 0.385, delta T, which we calculated here. First step is to multiply these two together. Then we have negative 676 equals M times negative 26.3. Divide both sides by negative 26.3. And you get negative 676 divided by negative 26.3 equals M. And your mass equals 25.7 grams. And you can see that right there.